Hello, everybody. I can't see nobody, so I just hope people are out there. Welcome, everybody, to the webinar today on SORA, a range of LoRaWAN. Just a quick introduction about myself and Sonte before we introduce the main man, being Andy Camsell. So I'm Phil Berry. I'm the UK and Ireland Sales Director for Sonte. And today's webinar is in the capable hands of Mr. Andy Camsell. Andy himself is a master systems installer. He's also a BCIA trainer and an expert on LoRaWAN. What there is to know about LoRaWAN that isn't needed to know, Andy doesn't know. Absolutely. He's also a Kent exile and a thoroughly nice man. So in connection with Sonte, he's running a webinar today. There'll be a question and answer afterwards on anything LoRaWAN related. I'll be available at the end with a few of my team if anybody wants to ask any further questions on SORA and Sonte. But after this webinar, my team and I are happy to reach out to us to come along and see you personally, give you a one-to-one on LoRaWAN, show you all the items that we've got in our range. Even happy to come along and do a site visit and see it working in action. We're doing that quite a lot around the country at the moment, so happy to do that. If you're really interested a lot more after this, just reach out to myself and we'll make that happen. So without further ado, it's all about LoRaWAN today, so over to Mr. Andrew Camsell. Over to you, sir.
Thank you, Phil. Just in case you didn't know, you're still on the screen, Phil. So, but yeah, thanks for the introduction. That was definitely better than last time, I have to say. Thank you. Last time I was like, oh, great. I should point out, just from what Phil was said there, I do have some experience with LoRaWAN, but my background is building services. So whilst I'm very flattered to be called a LoRaWAN expert, I am a building controls expert, and I would happily have that moniker. But LoRaWAN, I've been working with this. I do know stuff about it, but there's a lot of under the hood stuff where there's a lot more people who are better at this than me. So I'm going to get going with this webinar now. Phil's going to be online in the background, so when we get to the end, there'll be a Q&A. Phil will be available for that. So my name on there, Andy Camsell. I, as Phil said, I don't actually work directly for Sonte. I work very closely with Sonte, working in the field of building controls. LoRaWAN, as we'll see as we go through this presentation, actually has a lot of scope outside of the building services industry, and it's been around for quite some time before we started adopting this technology into the built environment. Yeah, we now see these products which are being made available specifically for building applications, and of course Sonte being at the heart of that, looking to develop their range, and I, because I love playing with things, get to test this stuff for them, so it's kind of cool. Works for all of us. The webinar format itself is quite a short webinar. You know, I'm going to take up your whole morning with this. Just a few slides about LoRaWAN. It's really aimed at people who have not used this technology before. And one thing I will say about LoRaWAN is that every time someone uses it for the first time, they're amazed by it. They're not expecting it to be as good as it is. And it really is a awesome technology for radio sensors, for wireless sensing technology. So it's a short webinar. There's about 15 slides with some details on LoRaWAN, what it does, how it works, not in huge amounts of detail, but enough. And then a look at a case that we had where we used the Sonte product, which is SORA, to actually, we had an issue on site, we had a challenge, and LoRaWAN exactly met that, and why that SORA product was perfect for the application. And we've also got a couple of interactive bits as well. So hopefully some of you are watching with a web browser. So there's a couple of polls in there that I would really appreciate you getting involved in, because otherwise, I might just be sitting here in my back bedroom talking to myself. And there is a Q&A at the end. So, obviously I can answer questions, or Phil is there able to answer questions as well. So we're going to start with LoRaWAN overview. Then we're going to look at the benefits of using LoRaWAN for BEMS. BEMS, Building Energy Management Systems, and then a quick look, as I say, about these at the SONTE Open Range Application, SORA, which does really feel like one of those acronyms that they were just desperately trying to find some way of putting it in there. But it is a really good set of products available from SONTE using the LoRaWAN technology. So the first question is, what is LoRaWAN? You may already know the answer to that, but LoRaWAN stands for Long Range Wide Area Network. It is, as it says on here in the notes, it's a low powered RF sensing technology, which is really important for sensors, because when we are putting sensors on walls, it's unlikely that we will be able to have a power source for those. So whilst Wi-Fi is everywhere, we use it all the time, you actually need quite a lot of power to drive Wi-Fi. We do have battery powered devices. Our phones typically will support Wi-Fi, but your phone needs charging every day. You can't change the batteries on a sensor every day, so we need a low powered technology, not something like Wi-Fi, which is very, very capable for large data transfers, but not really suited to small amounts of data being transmitted from a sensor. So we've got this low-powered technology. It's actually designed as an IoT technology. Now, I'm sure everybody has heard the buzzword Internet of Things. It's one of my pet peeves as it goes, the Internet of Things. It's like we couldn't think what to call it. So the Internet of, I don't know, things, that'll do. So the Internet of Things really describes technology where we've got machine-to-machine interfaces using the internet without human interaction. And when you think about what the internet was originally designed for, it was people interacting with computers or using computers to interact with each other. Now we have machines doing that, or we have devices doing that. So we refer to that as the Internet of Things, and LoRaWAN very much sits in as an Internet of Things technology. When we look at the architecture of the LoRaWAN system, you'll see how it has been developed around that IoT technology. One of the defining features of LoRaWAN is the range at which it can transmit. And this is the thing where most people who've not used it in the built environment before actually will use it for the first time and go, wow, I wasn't expecting it to do that, because it is quite astounding. There is an accepted indoor range of 200 meters and up to 10 kilometers outdoors, but the range can get quite a bit beyond that. So these are the accepted ranges. Now, lots of things will affect radio, radio transmissions in the same way that any other RF technology is affected, your mobile phone signal or things like that. But one of the things with LoRaWAN is it has capability to switch frequencies, so to choose frequencies which are most appropriate for the environment that it's in, which is pretty clever for a technology which is using such a low power. So this 200 meters indoors and 10 kilometers outdoors gives us a huge range that we can sit just a battery powered sensor and actually get a reading back from that sensor. But it can go a little bit further than that. And this is where our first interactive part is going to come in. So I've got a question for you. I'm going to open this poll in the browser here. Do you think that the current distance record for a LoRaWAN communication is A, between 30 and 50 kilometers, B, between 50 and 100, C, between 100 and 200, or D, greater than 200? So if you've got a browser, you could do that. See, effort's been made here. Look at this. Just give me a few moments. I love the music. There's a lot of jeopardy with this music. It's all I could find that was royalty free. I wanted the countdown music. Apparently you can't do that. Okay, so we've got some answers here just to let you know, because I don't know if everyone can see this on the screen. We have got 33% of our audience, I reckon between 30 and 50 kilometres, which seems reasonable given a 10-kilometre range outdoors. 16% between 50 and 100. No one went for the 100 to 200, but half of you went for greater than 200, which seemed like a sensible, if it was a sensible guess, because of course it's going to be a long way. It is actually 1,336 kilometres, which is 861 miles. This is truly astounding. This is a battery-powered device on a vessel which was just off the coast of Portugal, and it was picked up by a station in the Canary Islands, 861 miles away. That is how astounding this technology is. Now, of course, there was a line of sight. Everything was set up. The atmospherics were perfect for the day. You're not going to do this on a normal day. But it just shows you the power of this technology. And this is why it has become so useful in buildings, particularly where we've got lots of attenuation in modern buildings through just the fabric of the building, the insulation, the reflective surfaces that we have in there as well. So putting a LoRaWAN system together, it's made up of a number of different components, different layers. Essentially, we start with these, which are the end devices. So the end devices are your sensors. This is a temperature sensor, a CO2 sensor. We have people counters. There's all kinds of different sensors. Some can be powered, but generally speaking, LoRaWAN is developed as a battery-powered technology. But you can power these from an external source. So depending on the amount of power that your type of sensor will actually consume will depend on whether you need to externally power or battery power it. But end devices, if we think in terms of a temperature sensor, it's a battery-powered device which will sit on the wall. We then have gateways. Now, in a traditional system architecture, what a gateway would serve as is a gateway between the LoRaWAN network and the internet itself. So it would basically move the LoRaWAN signals from a LoRaWAN transmission through a gateway and into or onto the internet. So it would typically put that either through a GSM router, which would not be a sensible way of doing it. It's one of the reasons we have LoRaWAN, is to get rid of GSM routers. But we also would see this, routed through an internet connection. So if you're in a building, for example, you would have a LoRaWAN gateway or multiple LoRaWAN gateways, and your sensors would connect to them, and then they would transpose that LoRaWAN data or the LoRa data onto the internet and up to the next device, which is our network server. Now, network servers are the component which allows the system network, a logical network, to be built. So you can build a network server which will look after, let's say we were doing buildings, you could have it looking after 3 buildings, but each building would have just gateways which would move up to the network server, and then we could build logical network servers to one for each building, so that we had different networks. And then the network server will pass the information through to an application server, which will then push through to the application. So in terms of an application server, certainly for us in BEMS, and we'll look at this example in a moment, an application would be something like a protocol that we would use, so probably BACnet. But in terms of IoT technology, that application may be some kind of visualization or API. So it's creating the data into an API, which is then made available to another application on, online, some visualization technology, something like that. So we can create graphs, put it in a database, whatever. So in a traditional system, these would sit in your building. This would typically be in your facility as well. But the network server and application server would traditionally be online. They don't have to be. You could have those on premises, but traditionally, these would be online along with your applications. This is why it is described as this IoT technology. There are various components of the system that are taken care of at different stages in this. People often refer to this as a software stack. So things happen. If you think about stack, it passes through the layers of that stack, and things happen on the way through. Part of that is the security of the system. Now, the security of the system is really important. It's actually built in, and it's embedded into LoRaWAN like we haven't had with other sensing technologies, or the precursors to LoRaWAN or previous technologies, because it's been designed to work on the internet. So, for example, the network server takes care of encryption from end to end. So any data which comes out of a sensor is end-to-end encrypted through this entire process. But encryption requires keys in order to work, and there's two ways that you can get keys. One is to use pre-shared keys. So the device has a key in it, and then you have a key in your network server as well, and then all of those communications are encoded, or they are encrypted end to end using those pre-shared keys. But that's not a very secure way of doing things. Firstly, as soon as someone's got the key, because it's a pre-shared key, it's a key which doesn't change, then the system can potentially be compromised as a result. So it's not really secure from that point of view. All the devices are using the same key, and if you want to change the key, then you may be able to reprogram a key into the end device yourself. But more likely, if you're using pre-shared keys, you would probably have to send your sensor back to a manufacturer to get the pre-shared key changed, and then changed at the network server, which you're probably managing yourself, so the communications can commence. What is much better and is way more common is using what are known as session keys. So the session keys are a set of encryption keys which are dynamically generated by another device in the network, and that's a join server. So sometimes, in addition, I'm just going to flip back a slide, in addition to this network server, you have a join server. So devices will connect to the network, but then they will connect to a join server. The join server will actually issue the keys, the encryption keys for the session, and then everything is encrypted end to end. But if you need to reissue keys, then it's a much more straightforward process, because you just create another session and a new set of keys are issued. Now, session keys, when we are working on the internet, if you're working with a browser, you get session keys whenever you connect to a secure site. Those are issued relatively frequently. So every time you go to the site, you'll get a new session key for that session. But with LoRaWAN, a session could last months, if not years. It may be that your session never ends. You join the network and then it remains joined for the lifespan of that sensor. But the fact is, it is a dynamic session, so we've used that join server to get in there. So the end-to-end encryption is only part of the LoRaWAN security. There are other inherent security features as well. For example, one of the things that they do with LoRaWAN is that they use frequency hopping. So there's a predefined frequency hop. So when it's negotiating frequencies, it misses things out in a manner which is expected by the network server, and so devices can be authenticated, or it stops actually over-the-air attacks where people are trying to tap into your network communications. There's all kinds of other stuff in there as well. Things that we don't necessarily need in building services, but LoRaWAN, because it has its scope way outside of building services, you could put this in refrigerated transport trucks and be driving those all over the place. You're probably using a public LoRaWAN network for that, so you need to make sure that everything, or all your communications, are as secure as possible. It's difficult to know what information would be useful to a hacker, but presumably, if you've got a large-scale refrigerated transport system and people were able to find out where all the trucks were at any given moment, although I can't think off the top of my head how you might use that information in a nefarious manner. I'm sure that there's someone out there who would think, I don't know what I can do with this, how I can make a few quid. So having security built into LoRaWAN is really important, really fundamental to how it works. When we're working in a building, though, we don't normally have all of these devices at different in different places. So yes, we have sensors, but instead of having gateways and network servers and application servers at disparate locations or in the cloud. What we will typically have for an on-premises solution is a single board computer which will have the network server, application server, and sometimes the join server in there as well. Now this device here, this is the SORA main gateway that they sell. It's most people know it's a product which is made by WattSense and sold through Sonte, but there are some special changes to the Sonte one which make it particularly well suited to the SORA range. But inside this device here, it has got the gateway. So this one of these antenna here will bring in the LoRaWAN signals. That will act as a gateway, which will then be able to manage the network from in here. And then we also have an application server, which for this will turn that, the application that we get out of it will be BACnet over IP. There's certainly an RS485 port on here. I'm pretty sure it does Modbus and BACnet MSTP. Couldn't be 100% sure on that, but it definitely does BACnet over IP and Modbus. And I think there might be a KNX connection on there as well. So those are our applications. It's not like Word or Excel as in terms of an application, but we make use of those protocols in terms of an application. In this particular model, the join server is online. There is actually, when you purchase one of these, there is initially you will need to be able to connect to the internet through a GSM connection in order for the join server to join these sensors to the network. But after that, it will carry on working. You don't need that GSM connection beyond joining. Like I say, session keys can last for the entire lifetime of the sensor network, so you don't need to maintain that connection if you don't need to. The usefulness of on-premises solutions, of course, are that we can get all of our RF data into RF radio frequency data into a format which is useful or usable for us. BEMS, we're starting to see devices that talk LoRaWAN now, but generally speaking, we are going to need another protocol. And if we're talking open protocols, then probably BACnet IP is still the most predominant protocol that we use within BEMS. So having one of these devices which provides our sensor data as BACnet objects on premises is really useful. Something that is interesting about this particular gateway, this is what it looks like when you buy it, and these antenna are actually connected to this box, and it's a DIN rail mounted box. A lot of people put these inside metal control cabinets. If you're inside a metal control cabinet, then you do have a little bit of a problem because it's a Faraday cage. It doesn't, it will actually cause radio waves to be grounded. So it does reduce the capabilities. But again, very surprisingly, they do still work. It's much better if you're ever deploying one of these to have the antenna outside of your metal enclosure because it will work much better. You'll have better range with having those external antennas. Or antennae. Why LoRaWAN? We've had radio sensors for ages. I remember buying some radio sensors in the 90s. So what's different about LoRaWAN from any of the other sensing technology that we have? Well, there's quite a few differences. The first one being that transmission range. What we've seen with radio technology in BEMS and sensor radio sensing technology has been this development where we started off with point-to-point sensors. So you would buy a sensor and a base station, and there would be a communication between the two. It was generally use sort of VHF frequencies. They weren't great. The range wasn't great. The battery life was appalling. It used to use 9-volt batteries, and you'd be lucky to get 6 months out of one of those, maybe 3. So it wasn't a really useful technology. It's the kind of thing you would only use when you desperately needed to get yourself out of a hole. So the range was a problem. The battery life was a problem. LoRaWAN's addressed both of those things. So LoRaWAN has this really high transmission range, and it achieves that through choosing the most appropriate frequency for the environment that it's working in. The battery life is just off the scale. A temperature sensor now with a couple of 3.6 volt lithium cells in will give you around about 10 years worth of life. You broadcast the temperature every 15 minutes and it will give you 10 years worth of life. They just sit there working. Yes, you need to change the battery once every 10 years, but that's once a decade. It's like you put a new one of these in when you're 20 years old. You're only going to have changed the batteries 3 times by the time you're 50. So it's not, it's not like we're constantly performing maintenance on these things. And it's worth pointing out as well that the battery is monitored in most devices. So when the battery voltage starts to drop, you will actually get an interactive signal to tell you that that's happening. So the battery life is incredibly good. Like I say, it does depend on the type of sensing technology you've got. CO2 sensors need more power, so they don't have quite the length of life, but it's good in all instances. We also have the ability to use multiple gateways, creating a single logical network, which makes it a highly scalable solution. Most of our deployments for LoRaWAN are going to be small scale, I would guess, within the built environment. Small enough to have a single gateway. But if you needed to add multiple gateways, it wouldn't be a problem. If you wanted to have a gateway on each floor, for example, and create one single network server to manage all of those floors, it would be, eminently doable. One of the biggest blocks for this type of technology seems to be people's historic view of radio sensing technology. And just to sort of illustrate this point, there is another quick poll here that I'd just like you to do if you wouldn't mind. So in this one, and you can probably see where this is going. This is really about your telephone habits. So if you're at home, do you use a mobile phone? Do you use a landline? Or do you use those about the same? So there should be a poll on your screen now. This is the second poll I've got about the mobile phone. Then I will switch back to the webinar. Okay. Yes, switch back to the webinar. 100% of people say they use a mobile phone at home, which is unsurprising. That's kind of what I was expecting people to say. We've switched in many aspects of our life from using fixed wired technology through to using wireless technology, and we've done that without even thinking about it. And yet there still is quite a lot of pushback against the against radio technology for sensors, and a lot of it comes through this sort of we need extra maintenance for them. It's like I say, battery life is so long that we don't tend to need to worry about that too much. And there are commercial benefits to this, and you're definitely seeing the slides now rather than just that poll that was up there from before. So the commercial benefits of deploying a radio sensing technology. It negates the need for wiring to field devices. Fairly obviously, you don't have to install wiring. There was a really good video from Phil, who you saw earlier on LinkedIn the other day. He was talking about sustainability in that respect. If you're not putting wires in, then there is a sustainability benefit from that. It's a whole bunch of PVC and copper that's not going into your building. There is an ease of system expansion as well. Done this myself, needed to put an extra LoRaWAN sensor onto the network, literally just put it on the wall. That was it. Minor bit of configuration to get it working, but you can expand the system incredibly easily. And there is also a flexibility of the system architecture. Now, I haven't actually done this myself, but if you had an on-premises solution and you then wanted to start using your sensing technology instead of communicating with your BEMS, you just wanted to gather data and put it into some online database or something, then you could switch to having a gateway which pushed things up to Microsoft Azure or an AWS solution, whatever it was. So you can expand it, but you can turn the system into whatever you need to. You just remove the various components which are started off as a hardware base and turn those into gateways, put the network server and the application server online. The thing with LoRaWAN as well is that larger networks will give you better savings. There is a capital cost to this. If you purchase a LoRaWAN gateway and you purchase a single sensor, then obviously there's quite a lot of cost for one sensor to give you value. But that LoRaWAN gateway or that LoRaWAN gateway device will support multiple sensors. So if you've got a system where you need 20 sensors, obviously you still only need one gateway. So it starts to become more cost effective at scale. So the larger network, the better this is going to be. One thing that we do still tend to do, though, and I'm personally guilty of this, is that we still don't see it as a viable starting point. We tend to put this in as a retrofit technology when we can't get wires in. Now, there are commercial reasons for that, which I get. I work in construction. I do understand when all the ceilings are out and everything, it's not very expensive to run wires through existing routes, particularly if someone else has put the containment in. And so there is, the additional capital cost of putting a LoRaWAN network in can actually be comparatively high. But as soon as all that, all the finishes go up and everything, that system is then fixed. So that's where it is. If we have an opportunity to put a wireless network in from the outset, then of course we can expand that as much as we need to meet the customer's needs on an ongoing basis. And it's relatively straightforward to do. With LoRaWAN, you're not needing to put extra hubs in, extra routers in to route the communications through. We can simply put new sensors in and use our existing hub technology. Phil has sent me a message in the chat. I just want to say, Phil, that's not how you spell donut. I am one, but that's not how you spell it. Sonte Open Range Applications SORA. Now, this is obviously the Sonte product. It is based on proven LoRaWAN technology. So it is reliable LoRaWAN technology, but it's also reliable sensing technology. Sonte has recently celebrated its 50th year in this industry. They are really, really good at doing sensing. I'm not just saying that because they're paying me to do this. Genuinely, you don't do something that long without being good at it. So we've got our proven sensing technology here, and that's been adapted to fit with this LoRaWAN technology. Something else that SORA allows you to do is to rapidly deploy your systems. And this is really important. This is something that SORA does, which others are starting to do, the pretenders. Other people are starting to do, but for a long time, LoRaWAN was like a hobbyist type of system. You could buy all this different stuff, but you had to know how to make it work. You had to get your various components and then get them talking to each other, maybe understand some JavaScript to get it going in some instances. Certainly one gateway I was working with in the early days, you needed to know Linux quite well, how to work with the shell in Linux in order to make it work. SORA doesn't do that. With SORA, it's designed for building services engineers. So you buy the gateway, you buy the sensors, and they work together. Now, it is adaptable. You could do other things with it, and that might take a bit of your time. But if you buy the things that go together, Sonte have done the work for you. So that rapid deployment has been really useful within. Also has flexibility beyond that, because you could use the SORA sensors in other people's networks as well. So you can use the SORA range sensors with some other gateway, or directly deploying that online, as I have done in one of the experiments that I did. I don't think Sonte asked me to do it, I just did it. I took one of their sensors and I connected it to the Things network, which is a public LoRaWAN network. And I travelled from where I am in Northumberland to Leeds with the sensor, no gateway, nothing. And it just carried on working because I was using a public LoRaWAN network. So I sat in my hotel room and off it went, started working again. So we could use the SORA sensors with existing networks, and we can incorporate other sensors into the SORA architecture if we need to. This is a use case scenario that is a real world example. This is something we did in the company I work for. We had a passive house school in Buckinghamshire. If you're not familiar with passive house is a type of building technology where buildings are very well sealed, and so you need to have mechanical ventilation, heat recovery in there. The idea of a passive house, because it is heated passively by the people in the building, then you don't use much energy. So that's what a passive house is. One of the things that happened with this school was that they needed to achieve BREEAM compliance. And for BREEAM, which is the Building Research Establishment Energy Assessment Method, they needed to achieve compliance with that and the passive house standard. They, quite late in the project, discovered that in order to achieve that compliance, they needed a lot more sensing technology there than they'd allowed in the original contract. So suddenly we had to be monitoring CO2 and temperature in a lot of spaces in this school, which originally they didn't think they were going to have to. And because it's passive house, there was a limited ability to route cables through the space. This is a very sealed building. Every room is sealed and insulated from another. There are very restricted air paths through this building so that it works as a passive house building. And I'm sure you can see where this is going. So we've got a building that we can't drill holes in the walls. We can't drill holes through the walls, not without sealing them up. And also the construction of this school as well is very well insulated. So of course SORA was the perfect choice for this deployment. We were able to get a whole bunch of sensors. No wall penetrations were required at all. We could simply just put the sensors on the walls. There was actually one space where we weren't even allowed to drill into the walls, but we could just Velcro this thing to the wall. It's not pretty, but it worked. And the LoRaWAN technology permitted that RF transmission through the very solid building construction as it was. Now, there is one thing which isn't on here, which we did have to do. We had to get an external antenna. And it needed to be quite a large one as well, just to go on the control panel. It's quite a big floor plate for this school. So we had to get this external antenna, but with the exception of that external antenna, it was a straightforward off-the-shelf deployment. And I think we did it in a day. We added whatever it was 15 classrooms, both doing temperature and CO2. Literally in a day, everything was on the BEMS, and it was all done on the head end, finished. Can you imagine doing 15 sensors, running them out from a point, even if the school is already networked and you've got to put new controllers in, it would be a nightmare. So it provides a really useful benefit in terms of rapid deployment in spaces, particularly where you can't run cables. And so the client had their actionable data available in a very short space of time. We forgot all the sensors for BREEAM, and then including delivery, us getting there, putting it all in. I think it's about 3-4 days later, whole thing sorted, thanks to LoRaWAN, or specifically to the SORA product. So in summary, LoRaWAN itself has an incredible transmission range. That is the thing which really, more than anything else, gives it its edge above other technologies. And like I say, we've seen 800 miles. Yes, that's not normal, but that is an incredible range for a battery powered sensor to send a transmission. Extended battery life. Huge battery life is totally possible with LoRaWAN. Again, temperature sensors, which tend to be quite low powered devices. 10 years is a normal amount of time. If you've got two 3.6 volt lithium cells in a battery powered sensor, then if it's a temperature sensor and you're transmitting once every 15 minutes, you could fully expect to get that 10 years. That's not excellent solution for compliance and post-contract expansion. So for compliance reasons, BREEAM was a compliance issue there. And then we also see, expansion of a system, which is why we need to think about this more carefully at the outset of a deployment. Rather than thinking of it as a bolt-on technology, why not put it in at the start? And then as we develop our relationship with the client and we need to provide more sensing solutions so that they can have more actionable data from their facilities and make better decisions about their energy usage. If this is in from the outset, it's like, yeah, okay, we can get another 10 sensors for you. We can have those installed by the end of the week if it's there from the start. So it's a good technology to consider from the outset. The initial outlay is higher. Anything which is going to be using that much technology is going to be more expensive. But the reduced installation costs can sometimes offset that completely, and that's why it's very much used as a retrofit technology for us, for the scenario that I gave you in the school. Yeah, it's an absolute no-brainer. It would have cost a fortune to put it in as hardwired sensors. So being able to put RF technology in, so LoRaWAN technology in, meant that we did not have to put any wiring in. It was much cheaper to do that. But even at the outset of a project, when all of those ceilings are open, it can still be cost effective, because you only need to have missed one sensor and suddenly you've got a problem. Whereas if you've got LoRaWAN in there, we missed a sensor. Oh, okay, we'll get one from Sonte, we'll pop it on the wall with a bit of Velcro. So, the costs are higher, but the benefits usually outstrip the costs moving forward. Like I say, just a short webinar on that, with half the slides missing. I'm just not going to forgive myself for this. But we do have a Q&A session now. There is on the online an opportunity for any questions that you might need. Phil is standing by in the wings. I'm just going to bring Phil back into that so that he can berate me for my idiocy. Hello, Phil. Can you hear me all right?
I can hear you, my friend. Yeah, that was hilarious. Well done. I know what you're like. You've done that on purpose.
I wish I had. I just can't forgive myself for it. There's no questions coming in at the moment. Is there anything you would want to sort of add about the SORA range? Something I missed there, maybe?
No, that was first class. There's nothing like the proof of concept, and we've got 8 test kits in the company. We're happy to either send those kits out to people, they can keep them for 4 to 5 weeks, try it out for themselves, or we're very also happy for B, to one of my team to come along to any particular site and set it up as easy as you said. We just literally put the sensors wherever you feel you want them, put them on the second floor or the third floor, open up the laptop and start seeing the readings coming in. It's the easiest test kit there is going. So happy to do that to any particular customer. Happy to present to anybody that needs to see those slides again. I actually put all of the slides in when I do it, like yourself. And we can also show cost savings, etc., etc. So all that is available for anybody that's interested. Just reach out to us.
Okay, well, thanks, Phil. There's no questions in there, but obviously, if anyone does have any questions on that, I'm on LinkedIn. I think there's only one Andy Camsell doing building controls on there. So if you need to find me, you can find me on LinkedIn. Obviously, Sonte have a huge presence online in various ways. I think sonte.com. You'll be able to find all of the contact details should you need them. Thank you very much for watching this webinar. Appreciate your patience with the lack of slides. I will find a way of getting those slides out there, overlaying the narrative on top of the slides that should have been there somehow. So we'll be able to distribute that if anyone is interested at a later point. So thanks a lot. I'm going to shut that down now. Thank you, Phil. And hopefully...
Thanks, Andy. Don't beat yourself up. It was first class, sir. Well done.
We'll see you at another one in a few months' time. Thanks a lot. Bye now.